So multi-threading is always faster than multi-processing. Okay, and there are two ways to create a thread. What are those? Extending thread and implementing runnable. So extending thread we have already seen, I believe last class. We will start from there, implementing runnable. Okay, so second way to create thread is implementing runnable. So what does implements means? Implements means you will implement some sort of interface. Okay, so I will just write the code snippet which we follow here. So public class, you can give some name called myRunnable, implements runnable, myRunnable implements runnable. Okay, and automatically what method will be called? Tell me. Run is the method which gets executed here. Run is the method which gets executed. Okay, and whenever you want to invoke it, where will go? You go to the main method. You go to the main method. Okay, and inside main method, what to do? You have to create a thread, right? So first you have to create the object of your runnable. So how to create an object of runnable? MyRunnable, MyRunnable equal to new MyRunnable. Okay, and after creating a runnable object, you have to pass it to thread. You have to give it to thread. So how do you give it? Thread equal to new thread. And what you have to pass? You have to pass the runnable object which we are having. Runnable object. Okay, and after this you just use thread dot start. Start is the method. What is the method name? Thread dot start. That's all. That's all. So this is the syntax which we use to create a thread. Okay, so let's write it in our Eclipse. If you want to create thread using implemented runnable, how you do? This one was our extending thread, right? So I'll just comment it. I want to implement using runnable, so very simple. I'll go here. We'll create the class. What is the class? MyRunnable. Let's try to give the name called MyRunnable only. Okay, MyRunnable, finish. MyRunnable. What should happen? It should implements. Tell me, runnable. Okay. Automatically, as we know, if we implement any of the interface, what you have to do? You must implement the method also. So what is the method which is present inside runnable? Tell me. Run is the method. So if you see here, run method is the one which is it will come now. Automatically run method came, and similar to your previous one, suppose we want to print that number till 100, we will print here also. Similar to your yesterday, what you are doing, you are printing this till 100. Okay, yeah. Now we'll go to main class. What is main method? Main method is nothing but the entry point of our project. So if you want to run any sort of thread or anything, you have to start from the main method. So first we have to create the object. So how will you create my runnable? My runnable, you can see something like object equal to new my runnable. Okay. Now after creating object, what you have to do? You have to pass it to thread. Okay. So how will you pass it to thread? Thread equal to new thread, and you have to pass that runnable object. Okay. So just pass this command. Same thing. I mean, we have discussed a bit earlier, right? I am writing the same code only. This code. Okay. Now if I want to start the thread, what is the method name? Thread dot start. That's all. Now if I run this code, what should print? It should print the number from 0 to 99. Okay. We'll run this code. Control F11. 0 to 99. So all those are coming. Now if you want to give a name to a particular thread, how to give a name to a particular thread? Tell me. Thread dot set name. Set name. I'll give, suppose this thread name is Shiva thread. And if I run this code, what will happen? I am printing the thread name also, which is printing. So this is the way how you can run the things. Okay. Yeah. Now try to understand this very simple thing which I am doing. Okay. So last class also we have discussed this. Suppose if I want to prepare one big building, I am employing one person. Okay. Suppose the person name is Tapas, who is preparing my building. Okay. And he is taking 10 days to prepare it. So how many days he is taking? 10 days. Now suppose there are two persons who are working. One is your Tapas, okay, and another name is Shiva. Suppose Shiva is one other name, who is working for the home. Then approximately how many days they should take? Because two persons are working means approximately 5 days. Not exactly 5, you don't know. I mean, there will be some dependency with other stuffs also, right? So but it will definitely be less than 10 days. Got it, right? Similar to this, try to understand. Let's try to think about the thread. Okay, so what is the name of the thread? Tapas thread. Suppose Tapas thread is taking 10 milliseconds to do the task. Then if two persons are working, two threads are working, Tapas and Shiva, then how much they should take? They should take 5 milliseconds approximately. Got it, right? So but both will have to work together. If we will write the code normally, then what will happen? The code will execute sequentially. What does sequentially means? Line number 1, then 2, 3, 4, 5, 6. It will not be, it will not be mixed enough. So if this will be sequential, how many days we will take? Again, we might take 20 days also. You never know. But if both are working together, then how many days? 10 days. If both are working, sequentially, then how many days they will take? They will also take 10 days only, right? Are you able to understand what I am telling is? But if they will work parallelly, then only it will be less. Okay, so now let's try to do this. Very simple example which we will do here. Okay, so suppose we are printing this number. Okay, printing like this. Okay, suppose this is who is printing, this is Tapas is printing, and this is Shiva is printing, and both are sequential. Sequential means this is first, then second. So suppose I give the name called maybe Shiva. Okay, and this is then how the output will be 0 to 99 Shiva, 0 to 99 Tapas. So it is sequential. I mean, by default, Java code runs in sequential manner. Okay. So let's try to see the output. What is coming? Shiva over. Then tapas started. Tapas. So they will exactly take the same time what your earlier implementation was taking. Okay. So will it be fast? No. Why? Because both are working in sequential manner. When the things will be fast, when both are working, Shiva tapas, both are working. And if you want to do those sort of implementation, you must have the multi-threading implementation. Okay. So let's try to have very simple example. What I'll do, we already have this thread one. Okay. So here we are doing this thread name also. What I'll do is I'll create one thread one equal to new thread one. Okay, and I'll give the name called thread1 dot set name equal to Shiva. Okay, and what is the task you want to do? If you want to start the task, what is the method you use? Start is the method name. Thread1 dot start. Okay, similarly I'll create one more thread. What is the thread name called? Tapas. Okay, so I'll give the name called tapas. Okay, I'll change the name to thread 2. This is also 2. This is also 2. Got it? What I'm doing? Okay, let's start both of those together. Okay, so first I have given the name. I am starting. Now tell me, will it be sequential? So tell me, first Shiva tapas will come, or how it will come? How it will come? So what is the meaning of thread? Thread means it will do the things concurrently. Concurrently means parallelly. Okay, so let's try to run this code and see the output. Okay, so are you able to see what is happening? Is it sequentially or parallelly? Parallelly. See, Shiva tapas. Then again Shiva tapas. Tapas. Then Shiva. Then tapas. Are you able to understand what is happening internally? When I am not using the thread, what is happening? The code was, so this is the code. Okay, so if I run this code, only first Shiva, then tapas. But when I am using thread, what is happening? Shiva tapas, both are working. Are you able to understand? Then which will be fast? Thread will be fast. Why? Because both are working parallelly, right? Parallelly means it will take less time than your sequential way, basically. Okay. So if we run this code, the other one which we have done. So if this one was taking 20 minutes or 20 seconds, then what this one should take? This should take 10 seconds only. Why? Because two person are working over there. Okay. So let's run this code. See, Shiva tapas. You don't know the order basically. See, Shiva tapas. Both are working together. So this is the advantage of your multi-threading. Means the task will be finished fast. Why? Because more threads are working. Okay. So note it down. Okay. So what you can note it. Okay. So if we have more threads working together, they won't execute the code sequentially. These will execute parallelly or concurrently. And as we know, concurrent will always be fast than sequential. Okay. So as we know, concurrent execution is always faster than sequential. So it will take less time. Less time means fast. Okay. Okay, so here Shiva Tapas both are working together, so it will be faster. Yeah, now coming back to the thing which we are discussing. Okay, so there are two ways to create a thread: extending thread and implementing runnable. Now the question will come, which is fast or not fast? I'll ask you which is good. Okay, which is good, extending thread or implementing runnable? Implementing runnable. Why? Why? Same method? No, method will be same, right? Run only. So which is good, implementing runnable or extending thread? Which is good? Implementing runnable is good. Okay, so implementing runnable is preferred. Again, it is preferred, not mandatorily. So you can use any one of those. If you are comfortable there, that also you can use. Preferred over extending thread. Now the question is why? Why? Okay, try to understand why. I will write the previous code. So how my code was looking like: public class, I have written this thread 1 extends thread. Okay, and automatically what was the method coming? Run was coming. Okay, and from main method what I was doing? I was doing thread 1 thread equal to new thread 1. Okay, and thread dot start. So this is the code which I was writing. If you see the line of code, thread will have less line of code. Why? Because here you don't have runnable sort of thing. Okay, so this is the extending thread implementation which we have done. Okay, now observe very closely. If I will extend thread, can you extend any other class? Can you extend any other class? Can you extend? Does Java supports multiple inheritance? No. So can I make it animal here? I want to do one more class, animal. Can you do that? No. But if you will do that other one, so what is the other one which you have seen today? We have seen here called public class. Okay, my runnable implements runnable. This is the code which you have written today, right? Now if I want to extend animal, can I do here? Extend animal, can I do that? Yes. Got the problem what you will face here, right? So because of multiple inheritance constraint, okay, so if you are extending thread, you cannot extend any other class. But in implementing runnable, what you can do? You can extend one thread, plus you can implement n number of interface also. There is no restriction for that. Got it, right? So yeah, note it down what we discussed here. Okay, so as we know Java doesn't support MI. Not MI means not Mumbai Indians. Okay, it is multiple inheritance. Okay, so Java does not support multiple inheritance. So if we extend one class, then we can't extend any other class. If we extend one class, then we cannot extend any other class. But in case of implementing runnable, what we can do? We can extend one extra class. We can extend one extra class, right? There we cannot extend one extra class. Here we can extend one extra class, and can implement n number of interfaces. Okay, so we can implement n number of interfaces, and we can one extra class also we can extend. So this is one of the reason why what happened, implementing runnable is preferred over extending thread. Okay, so this is one of the reason. Now let's go to the other reason. Okay, now suppose if we are doing one project, one small project we are doing in Android. Okay, and what I'll do is I'll give all the work to Zen only. I will not give it to other people. So is it good, or I should divide my work to all the people, I mean in a homogeneous fashion? Which is good? Divide it to everybody, right? Okay, so similarly here also try to understand. Okay, so if you are implementing runnable, there are two things you are working. One is thread, okay, who is starting the work, okay, and who is doing the work? Runnable is the one who is doing the work, because run method is inside this. If you see, run method is inside this. Got it, right? So again, same thing as I told. If we are extending thread, means I am giving work only to thread, means I am giving work only to Zen. But if I am doing implementing runnable, what is happening? There are two persons. One is Zen and another is runnable. So both are dividing that work basically. Runnable is only taking care of running the task, and Zen is taking care of starting the task. Got the point, right? So which is good? Runnable is better than your this one. Why? Because of it supports modularization. Okay. So not the second point down. Okay. So what is the second point? Runnable supports modularization. Okay, so what runnable supports modularization, which is the motive of Java. What is the motive of Java? Java supports modularization, which we are studying right till now. Okay, which is the motive of Java. So runnable supports modularization, which is motive of Java. Okay, so if we implement runnable, okay, so runnable will take care of running the task, and thread will start the task. Okay, So if we implement runnable, then runnable will take care of running the task and thread will start the task. So which is always better because we are having modularized fashion. Okay, so we are following modularization. So that's why implementing runnable is preferred over extending thread. Okay, so this is very typical interview question they'll ask. Okay, so first they will ask how many ways to create a thread, then you have to talk about 2 ways, extending thread, implement runnable. Then they will ask what is the difference between those two. What is the difference? In thread, only thread is running. Okay, runnable is running the task, thread is starting the task. Okay, and then they will ask which is good. Then you have to talk about implement runnable. Plus you have to give some sort of points also which will describe your claim. You are claiming runnable is better, right? So why? So you have to discuss it. This is very typical question which should be asked. So these 3 questions are very very popular and famous questions. Yeah. Now after this they will ask what is the life cycle of thread. Okay, based on your college you might have already studied, but let's look into that once again. Okay, so what we are studying? Life cycle of thread. Okay, these are also called states of thread. What are the states of thread? Okay, so these are the states of thread. First is your new is your state. Okay, second is runnable is the state. Okay, third state is running is the state. Okay, fourth state is sometimes sleep or block is one of the state. Okay, and fifth and last state is dead or terminated. Sometimes we say it is a terminated and sometimes we will take the dead. They are the 5 states of the thread. New, runnable, running, sleep and dead. Okay, so what is new state? New state is nothing but whenever you do something like you are writing some thread 1 equal to new thread, right? So you are creating a thread. So this creation of thread is called new state. Why? Because you are using new keyword, right? So it is new state. As soon as you will do new thread means it is your creation of thread, and the state name is called new. Okay. Now, what is runnable state? What is runnable? So as soon as you will write the code something like thread 1 dot start. This is called runnable state. Okay. Now try to understand this very. It is also a little important. Okay. So suppose as soon as you will do the start of your thread, your thread will start running automatically suddenly? How it happens internally? How it happens? Any idea? Okay. So let me write something. Okay. So suppose this is your new state. Okay, this is your new state. Okay, now from new it went to where? It went to our, what is the state? Runnable state. As soon as you will do, so this is your runnable state. Okay, RA means runnable. Okay, and here is your running state. RU means running state. Okay, now as soon as you will create new state, start runnable, then your work is over. programmer's work is over now. Okay, now whose responsibility is to take it from here to here running state? Who will do the JVM? In Java, who will do JVM? Okay, those are called thread scheduler. Who are called thread scheduler? In Java, JVM is there. Maybe in other operating systems, some other VM will be there. We don't know, right? So that's why what we will tell thread scheduler. Okay, so now thread scheduler will pull it and put it inside your running state. And based on the priority, there are many things which will come into picture basically. Okay, and that's why this runnable state is nothing but this is called thread pool. What is that called? Thread pool. Okay, so you will have many threads, thread 1, thread 2, thread 3, thread 4, many will be there. And who will pull them from here to here? JVM is the one who will pull them basically. Got the concept, right? So that's what. So as soon as you will start it, it does not mean it will run automatically. Now whose responsibility is there? JVM responsibility in Java. Okay, thread scheduler is on. Okay, now what is running state? What is running? Okay, so note it down. Okay, so what we can note it down? Programmers responsibility is to change the state of the thread to runnable. Programmer's responsibility is to change the state of the thread to runnable. Now it's thread scheduler. Now it's thread scheduler's task. It's thread scheduler task to move it to running state. Now its thread scheduler task is to move it to running state from thread pool. Okay, thread pool. We call it a thread pool. So what is thread pool? Pool of threads. Many threads will be there. Okay, so you have started one thread, other person has started one thread, other person has started. So all the threads will be in runnable. From runnable, JVM will pull it. Okay. Now JVM, what architecture they use, we don't know. It might be first come first serve. It might be round robin fashion. Okay. It might be priority based. You don't know. I mean, it is up to the operating system basically how they want to run that particular thing. Okay. So it is thread scheduler task is to move it to running from the thread pool. Okay, and in Java, who is thread scheduler? JVM is thread scheduler. In Java, who is thread scheduler? JVM is thread scheduler. Okay. Now what does running means? Running means run method started. So run method started. Running means run method started. Yeah, I am in a meeting. I will call you back. Okay. So run method. So now tell me, if run method got started here. Here means if you go to this thread. So this line has come, then what is the state? Running. This one will come when JVM already pulled it and put it in your running state. Okay. So this is your running state. Run method started. Okay. Now sometimes what we do, we'll study this. Don't worry about that. Sometimes we do this thread dot sleep. We'll study. Don't worry about that. Okay. What is sleep? Sleep means you want to block your thread for some amount of time basically. So we can pass some time here, something like 1000 milliseconds. Then what will happen? Your thread will be blocked for some amount of time. Okay, what is that state? That is called blocked or sleep state. Okay. And when dead and terminated will come when your run method over. I mean run method over means if you have reached the line number 10 here, this line means your run method over, means dead state. So this is your dead state. This is your dead or terminated. Dead or terminated. Okay, so dead terminated means your run method exit. Okay, so exit. Run method over. Okay, so if somebody will give you code, they will tell you this line which state, this line which state. Can you identify easily? Very simple. Okay, so new means it is your new state. Runnable means start. Running means run method. Run method is started. Okay, now run method over means it is your dead state. If you will do block, thread dot block or sleep or wait, we will see that, then it will be your, what is that, blocked state. Okay, yeah. Now let's try to understand. So this is that. What is the thread state? Absolute thread, new, runnable, running, non-runnable, that is called when you can block, and what is the last one? Dead or terminated. These are the states of your thread. And life cycle is controlled by whom? JVM. In Java, JVM is the one. So that's what I mentioned. New means new thread. Runnable means start. Okay. Running means JVM has scheduled it. What is the one? Run method is started. Non-runnable means sleep or wait. We will study while going through. And what is the dead one? Run method exit. Means run method. Okay. Yeah. Now this is the very simple diagram which you have to draw. Whenever somebody will ask any of the question, you should ask them the pen and paper, then you can explain in better way. Okay, so if somebody asks, hey, please tell me the thread states or thread life cycle, just ask him, can you please give me the pen and paper, then you draw the diagram and show him these are the states, which would be more, I mean, explainable basically. Okay, so always have pen and paper with you. So this is the diagram which should be there. So new, runnable, running, dead, waiting or blocked. Okay, so this new means same, new, runnable means your, what is that, start. Okay, running means your run method started, block means that one, sleep or wait, dead means over. Okay, now one small notable thing here is observe very closely. Okay, so these arrow are unidirectional, see, all the are unidirectional, but here we are having bidirectional. Okay, so what does that mean? If one thread was running, we have blocked it, it directly cannot come to running. It must have to go through runnable. Again, who will pull it? Thread scheduler, JVM, and then pull it in running. Got it, right? Or else running, runnable, it is fine. But if it is blocked, it cannot come directly running. It must go to runnable, and from runnable, JVM will again pull it. So here just make it bidirectional. In your notes also you make it bidirectional. All the other arrows are unidirectional, but here must be bidirectional. Unidirectional means only one side, not both sides. Okay, this is very important. Whenever you draw the diagram, you show him, I mean, this is the way, both sides. Other will be one side only, no both sides. Okay, it will be bidirectional. Got it, right? So this is the way how it works. Any doubt in thread state? Okay, so these are the 5 states, very important states. Okay, so this we have already seen what is starting a thread. So start method is used to do the start of thread. What it does is it creates new thread. Okay, and the thread moves from new state to runnable state. Okay, and when the thread gets a chance to execute it, what method will be running? Run method will be running. Okay, now let's try to understand what is sleep method. What is sleep method? We will discuss. We will discuss sleep method and we will finish. So for timing I just comment it. Okay, I'll comment it. So how many threads we are running? Only one thread. What is the name of that? Shiva. So now when I am running this code, what is happening? See, it is automatically running 100. Again, if I run this code, what is happening? It is running. So on the spot, I mean in one shot, your full 0 to 100 is running. Okay, you don't want to do that. In between all the steps, you want to wait. I mean, you want to block your thread for 1 second, 1 second, 1 second, 1 second, 1 second. Then what is the method you use? Sleep is the method. So very simple. I want to block my thread for 1 second. So where I'll go here. Before printing, what I'll do? Thread dot sleep. Very simple. I want to sleep, make my thread block for 1 second. Then it would be in milliseconds. So 1000 means 1000 millisecond. 1000 millisecond means 1 second. Okay. Now see, when I wrote this code, there is some problem. So what is the problem? What is the problem? What is the problem? Let's move our cursor, it will tell you. What is the problem? Are you able to see? Unhandled exception called interrupted exception. So tell me, is it a compile time exception or runtime exception? Compile time. So interrupted exception is one of the example of compile time exception. Okay. So note it down. Okay. So whenever you do sleep, you must handle what is interrupted exception. Okay. So very simple. You just go over there and handle it. That's all. So interrupted exception is one of the example of compile time. So what all compile time exception we have seen? Do you remember? Serialization we have seen. Class not found, then file not found, then IO exception. Okay, and interrupted exception. This is one of the example of the compile time. So these are 4-5 examples of compile time. Class not found, okay, and then file not found, then IO exception, input output. Then this is also one of the example of compile time exception. Then SQL exception, that is also example of your compile time exception. Okay. So now let's run this code. If we run this code, what is happening? See, it is not automatically running. It is waiting, blocking 1 second for your thread. Then it is coming one by one. See, in earlier case, one shot. Now what is happening? 1 second, 1 second, 1 second, 1 second. So 1 second interval is there between the execution of your whatever work you are doing, whatever task you are doing. Got it, right? So in between, whenever you want to make your thread block for some time, just use dot sleep is the method. Okay. So that's what sleep method. What is it? It is used to sleep a thread for a specified amount of time. Okay. Yeah, we will continue from here. Okay.